Now let's understand how can we create a binomial distribution step by step. Let's do that. So I'm here. So now we will create an example. So let's plot a binomial distribution. So first thing, step one for this is you have to determine the values of n and p. Okay, determine values of n and p. So n is the number of trials, as we have discussed before. N is the number of trials, and p is the probability of success on single trial, on each trial or single trial. So in this case, what would be our example? So our example, we will take up a coin, flipping a coin. So flipping a coin is our example. Let's take n is equals to 5 and p is equals to, obviously, probability of getting ahead. That's what is, let me write down here, probability of, this is my success. So let me put success here. Success is probability of getting ahead. That's what my success. And then that's very simple. It's 0.5. We everybody know about that. So this is what the first step. Then just a minute. Okay, plotting a binomial distribution for flipping a coin with the 5 number of trials. Okay, that's what step 1. And step 2, then we have to calculate the probabilities of getting each possible number of successes. So that's what the step 2, let me put it here. Step 2 is to calculate the probabilities of getting each possible number of successes from 0 to n. So we can use the formula that we have discussed. Let me see that formula one more time. Yeah, p probability of getting exactly x successes in n trials is given by this ncx p power x 1 minus p power n minus x. Let me write down that formula. So I'll say probability of getting success, capital X is success. So for me, the success, I'll write it down here. X is equals to success. What is that? My success is nothing but getting ahead. Getting ahead is my success. So that's what I'm representing, X. And probability of P of X is nothing but probability of getting ahead. How many times? I'll take here k times, because again, see, now if I use small x, then there will be a confusion. So that's the reason I'm using k here. So probability, when I say P of capital X is equals to k, means probability of getting ahead k times. What's the formula for this? Is equal to n, n choose k multiplied by p power k multiplied by 1 minus p power n minus k. Okay, this is what is our now probability of getting ahead k times. Okay, you know, and choose k is nothing but nck, which is n factorial divided by n minus r factorial times r factorial. Nothing much, nothing much. So this you can say n choose k is nothing but n factorial divided by r factorial. Sorry, here k na we are saying k, so k factorial times n minus k factorial. That's it. Okay, so this is what is our step 2. Now let's move on to the let's do the respective calculations here for the step 2. So what example we have taken, we want to plot the binomial distribution for the number of heads obtained when flipping a fair coin, I'm saying fair coin 5 times. So the number of trials for me is 5, n is equals to 5, and the probability of success, that's x, probability of success getting ahead is 0.5 for me, that I have put it here. So using the binomial probability formula, I will calculate the probability of getting p. Let me put it here, let me give some space. Yeah, so probability of getting success, that is x getting ahead 0 times. That's what my first calculation. Probability of getting ahead 0 times when you do when you flip a coin 5 times. What is that? So the formula is 5 choose how many times? 0 times multiplied by what's my probability of getting success? P 0.5, and what's the value? 1, sorry, 0, because that's what my k, multiplied by 1 minus p, that's again 0.5 power n minus k, that is 5 minus 0, that's 5. So this is what my probability of getting heads 0 times when you flip a coin 5 times, that is equals to 0.03125. If you want, you can calculate. I have calculated already. So then let me copy this 5 times. Okay, so p of x, probability of getting head once when you flip a coin 5 times. So 5 choose 1, and then this is power 1, and this will become 4, and the value that we will get is 0.01515625. Then again, probability of getting heads 2 times when you flip the coin 5 times is this 0 2, and this one will become 3, and the value will become 0.3125. Then next one, probability of getting success or heads 3 times when you flip a coin 5 times, then 5 choose 3, then here this will become 3, and this will become 2, and for you the value is 0.15625, same one, 15625. Then the probability of getting heads 4 times when you flip a coin 5 times is 5 choose 4, and 0.5 power 4, and 0.5 power 1, and obviously the value would be 0.15. Sorry, this one 0.3125. Just calculate. This one is 0.15625. Okay. So, and final one, probability of getting heads 5 times when you flip a coin 5 times. So it would be 0.55, and this is 0, and the value would be the top one, whatever you got here, 0.03125. So that's it. So the respective probability calculations were done. So now let me move on to the step 3. So step 2 is also done. Step 1 is also done. Now it's time for step 3. So step 3, so nothing else. Once you got the probabilities values, now we have to create a table or a list of the possible number of successes and their corresponding probabilities. Okay, so here that's what we'll do is simply whatever we have done, you can put it in a table, nothing else. Like how will you make the table? Number of heads, that's 0, 1, 2, 3, 4, 5. Let me do it here. So first one is number of heads, that's our success, capital X, but we represent this with number of heads uh, that we get with K. And then here we have probability, which is nothing but P of X, P of success. So for me, first number of success I want as 0, and the probability that I got is 0.03125. And after that, let me copy paste here. Yeah. So then I got for 1, to get the 1 heads, the value I got is 0.15625. And to get the 2 heads, the probability of getting 2 heads is 0.3125. And the probability of getting 3 heads when you flip a coin 5 times is 0.3125 again. And the probability of getting 4 heads when you flip a coin 5 times is 0.15625. And then final one, the probability of getting 5 heads when you flip a coin 5 times, it would be very less, you know that. So getting a 5 getting a 5 heads when you flip a coin 5 times, you know that the probability would be very less. Even with your rational mind you can tell, and that's what we got. It's very less, 0.03125. Okay, this is our step 3. Then once you have tabulated, so what we can do is we will step 4, we will basically plot a graph. Step 4, we'll use a graphing tool or software from pandas or somewhere, and we can plot the binomial distribution. Okay, so we can plot the number of successes. How do you plot? You plot the number of successes in x-axis, which is nothing but the k value in x-axis, and we can use a bar graph or a line graph to represent the respective things. So number of successes in x-axis, and the probability of respective k value is on y-axis. So if I put it here, It's P of X is X is this here. You can represent using any of this, the bar graph or line graph. So let us do that. Let's take the example, same example. Let's plot it in pandas. Yeah, we are here. Yeah. So first thing, let's import pandas as PD, and then import scipy dot stats as stats. Then first thing, we have to decide n and p. So let me set the parameters for the binomial distribution. So n is equal to 5, the number of trials is equals to 5, and then p, the probability of success. So p, the probability of success is 0.5. Okay, so these parameters are set. Now it's time to create a probability distribution object using binom function. So let's create a probability distribution object using the binom function. Okay, so dist is equals to stats, and from the stats we're going to use binom method, and n, these are the two arguments it's going to take, n comma p. So that's it. Our binomial function, or the probability distribution object has been created. So now let's calculate the probability mass function values for each possible outcome. So outcomes is equals to range of n plus 1. That's it. Correct. Now props. Now I want props. That's a probabilities is equals to distribution. That's the variable name that we have given for the binomial distribution function or object. So then I'm going to use PMF to calculate that. This is what we use, PMF, probability mass function, or PDF, or probability distribution function. I'll use probability mass functions here. So that's it. So this is gonna calculate probability for each outcome, for 0, 1, 2, 3, 4, 5, like that. So now let's create a data frame to store the outcomes and their probability. That's what we did here. We did it in table. So now create uh, pandas data frame to store the outcomes and their probabilities. So df is equals to pd dot data frame, and so it takes I need to create a key value pair, that's a dictionary. So number of heads, so it's nothing but my outcomes, then, and after that probability. So props, probability props consists of the probability values. So that's it. Data frame is ready. If you want to say, this is what. So for 0 heads, 0.03125, is it correct? For 1 heads, to get 1 head, the probability of getting 1 head from an experiment when you flip a coin 5 times, it's 0.15625. Probability of getting 2 heads when you flip a coin 5 times, 0.3125. Probability of getting 4 heads when you flip a coin 5 times is this, and probability of getting 5 heads when you flip a coin 5 times is this. Okay, so that's it. Our data frame is ready. So now it's we need to plot it, nothing else. Plot the distribution as a bar chart using pandas. So ax is equals to df dot plot, and so kind, I'm gonna go for the bar, and x, what's the x value? X is number of sorry, x is equals to, let me directly copy from number of heads, then y is equals to probability, and legend, I don't want it, legend is equals to none. So now let's set labels. Set underscore x label. So I'll write it down as number of heads, and x dot set underscore y label, which is probability, and finally we need to set the title, set underscore title, so which is binomial distribution for flipping a coin 5 times. So that's it. This is your plot. This is your binomial distribution. So number of heads, and it's by and large taking the shape of normal distribution. See that? This is how we create a binomial distribution, and this is what is called a binomial distribution. So this uh, created a bar chart of the binomial distribution for the number of heads obtained when flipping a fair coin 5 times, with the number of heads on the x-axis and the probability on the y-axis. The resulting plot will show the probability of obtaining each possible number of heads. So let's also do some kind of simulation for you so that you can understand this better. So I'm coming here. Yep. See this one. What I'll do is I'll bring it to the normal stage, everything. So what's the sample size that we, sorry, trial, what's the trial value? The number of trials would be 5. I'm putting into the 5, n is equals to 5. And then obviously it's a fair coin. Probability of getting head for me is 0.5. So now let's simulate. Let's simulate this. So as my number of trials is 5, so maximum the probability of getting success, probability of getting heads when you flip a coin, when you flip a fair coin 5 times. So I can have 6 options. Either I can get 0 heads, or 1 heads, 2 heads, 3 heads, 4 heads, or 5 heads. That's what we are going to simulate. Okay. So this is the distribution. This is the distribution, binomial distribution. You can see that, and whatever we got is also same. And see, this is what the binomial distribution we got, and this is what they got. So it's same. So now when I see, for me, if the probability of getting 0 heads when you flip a fair coin 5 times is 0.013, correct? And getting 1 head when you flip a coin 5 times is 0.1563. And 2 times, you can see that the red color, the blue color is becoming red. The respective number of times is here. The x-axis is obviously the number of successes you will get, and then y-axis is the probability of it. Then x when 2, and then 3 is this, 4 is this, and obviously uh, getting the probability of getting 5 heads when you flip a coin 5 times. You can see that the extreme values zeros and fives. So getting 0 heads out of 5 is very less, and then getting 5 heads out of 5 is also very less. That's the reason these two probabilities are very high, very less when it comes to the probability of getting the 2 or 3 is very high. That's what you see, that the probability of getting 2 heads when you flip a coin 5 times is 0.3125. It's high, and same happens with the 3. So now let's take 9, 15. Okay, I'll bring it up to the 50. So this is what, when you flip a coin, uh, if your trial is 50 times, when you flip a coin 50 times, what's the probability of getting 0? Obviously it's 0. What is the probability of getting 50? It's 0, absolute 0. But what is the probability of getting 25 heads? 25 heads when you flip a coin 50 times. It's high, it's 0.1123. And similarly 27, 0.096. So getting 16 to 30 heads is very high when it compared to getting 0 heads or getting 50 heads. So that's what is our uh, is a binomial distribution. So let us do one more simulation. So let's take, in spite of using a fair coin, we have used the biased coin. Biased coin, where the heads, the getting the heads, when you do a single trial, when you flip a coin once, getting a head, the probability of getting head is 0.8. Then how will it behave? Then obviously you'll get a skewed distribution, a skewed binomial distribution. That you can see that. Let me put it into the 25. You can see the skewed binomial distribution. So it's been skewed left. You see that it's been skewed completely left. So what will happen? Out of 7, let me take it to the 10. That would be much easier for us to, yeah. Now it, no, let me bring it to the 20. So now if you see this, it's skewed left. Clearly it's skewed left. So before, when it was 20, let me put it here, 5. So when it was 20, so when you get 10, when you get 10, when you ask the probability of getting 10 heads out of 20, when the coin flipped 20 times, it is very high. It's 0.1762. But when I have a bias, that time the same k is equals to 10 has been put into the skewed one. So what's the probability? It's just 0.02, because the coin is biased. The coin is biased. So most of the time, as the coin is biased, so it would be skewed completely left. The most of the data falls on the right. So that is the reason probability of getting 13 heads, 14 heads, 15 heads, 16 heads, 17 heads has higher probability. Even probability of getting 20 heads also is better than compared to the probability of getting 0 heads. Probability of getting 0 heads when you flip a coin 20 times is 0, but when probability of getting 20 heads when you flip a coin 20 times with the biased coin is again 0.015. So that's what I'm trying to tell you. If the coin is biased, you will have a you will have a skewed distribution, skewed binomial distributions. These are called skewed binomial distributions. Okay, this is a right skewed, and this is left skewed. This is right skewed and this is left skewed, and this is no skew at all. No skew at all. This is a fair coin. If you use a fair coin, and this is what happens. So this is what the simulation of the binomial distribution. I think I took huge amount of time to explain binomial distribution because it makes lot of benefit. It brings a lot of benefit for a data scientist. Maybe you don't know now, but in future you will get to know. I will explain how you can leverage binomial distribution.